Hi everyone, welcome back. In this Math 20-1 lesson, we are learning inequalities. We will graph linear inequalities in two variables, solve quadratic inequalities in one variable, graph quadratic inequalities in two variables, work with systems of inequalities, and identify feasible regions. Please like the video and subscribe to the channel. A linear inequality in two variables shades one side of a boundary line. If the inequality includes equals, use a solid boundary. If it does not include equals, use a dashed boundary. Test a point to decide which side to shade. To solve a quadratic inequality in one variable, move everything to one side, factor or find the zeros, split the number line into intervals, and test each interval. The solution is usually written in interval notation or inequality notation. Solve x squared minus 5x plus 6 greater than 0. Factor to get x minus 2 times x minus 3 greater than 0. The expression is positive outside the roots and negative between the roots. Therefore, x is less than 2 or x is greater than 3. A quadratic inequality in two variables shades above or below a parabola. First, graph the boundary parabola. Use a solid curve for less than or equal or greater than or equal. Use a dashed curve for strict inequalities. Then test a point to decide where to shade. A system of inequalities is solved by graphing every inequality on the same grid. The solution is the overlap of all shaded regions. This overlap is called the feasible region. Great work! For inequalities, identify the boundary, decide solid or dashed, test a point, and shade. For one-variable quadratic inequalities, use roots and interval testing. For systems, the solution is the feasible region where all shading overlaps. Like the video and subscribe for more Math 20-1 lessons.